The nose cap sustained very little damage. In general, the recovered pieces were quite large. The spray-on foam insulation exhibited varying degrees of thermal effects, from extreme charring to practically no effect. The external tank range safety destruct explosive charges housed in this cable tray were recovered undetonated, eliminating them as a possible factor in external tank breakup. The intertank region showed signs of buckling in the fore and aft direction. This would be consistent with the impulsive thrust that resulted from the sudden loss of liquid hydrogen from the aft section of the tank. This shearing failure of the forward attachment fitting with the right SRB was caused by the booster's rotation after the aft strut area failed. The stiffener stringers on the right-hand side of the intertank show evidence of contact which match marks on the forward assembly of the right SRB. A section of the ring frame and a section of the aft dome from the lower strut attachment area was recovered in one piece. The lower strut attachment fitting had been pulled away. The effects of the anomalous SRB plume can be seen on the external tank, excluding an area which was shielded by the strut and attachment fitting. Approximately 50% of solid rocket booster hardware was recovered. An ordnance storage facility was used to house the motor case pieces, as some contained unburned propellant. Marks seen on the right SRB frustrum match the contact area shown previously on the ET intertank stringers. The size and location of the burn-through, as indicated by the recovered SRB debris, were illustrated on an assembled booster. The aft center section of the joint shows a large hole centered at the 307-degree circumferential position. The irregular hole is roughly rectangular and is about 27 by 15 inches. The steel case material showed evidence of hot gas erosion caused by combustion products flowing through the opening. The aft section of the right SRB showed a hole approximately 33 by 21 inches. The burn surface extended into the aft attached strut region. The exterior surface of the aft case featured a large heat-affected area. The shape and location of this heat spot indicates an impingement from the escaping gases. There was a small burn-through in the case wall which appeared to have penetrated from the outside in. This was due to the impingement of hot gases from the anomalous plume. The hole in the solid rocket booster segments was the result of the joint leakage on the right-hand SRB, which was determined to be the cause of the accident. The Presidential Commission concluded that the cause of the Challenger accident was the failure of the pressure seal in the aft field joint of the right solid rocket motor. The failure was due to a faulty design, rendering the seal unacceptably sensitive to a number of factors. Those factors include the effects of temperature, physical dimensions, the character of materials, the effects of reuse and processing, and the reaction of the joint to dynamic loading. More detailed analyses are contained in Volume 3 of the report of the Presidential Commission on the Space Shuttle Challenger accident.
This picture may be our first glimpse of another solar system. Planets may be forming in the thin disk